Hello friends, so today we're going to be solving this question, minimum path sum. Let's read the question description first. Okay, so we have given an m cross n grid matrix filled with non-negative numbers. So all the numbers will be always positive, right? And we have to find a path from top left to bottom right, which minimizes the sum of all numbers along its path. Okay, and you have only given two options. You can either move down or right. So let's say you're standing at this index, which is this point, which is 0th row, 0th column for this matrix particularly. So you can either move to the right, which is 0th row first column, or you can move to the first row 0th column. Okay, that's it. And here if you have to start from here and you have to reach here, bottom right, bottom right. Let's see, this is the bottom right. So from here, this point, top left, you have to reach till bottom right. So which path is going to give you the minimum sum? So let's see. Okay, so 1 plus, let's say we are traversing like this from 1 1 4 2 1. If you're going like this path you're choosing, so the sum will be 1 plus 1 2, 2 plus 4 6, 6 2 8, 1 9. Let's go from this path. 1 3 4 4 1 5 6 plus 7. So this is the minimum, so that's why the answer is 7. Let's see just in the diagram so you'll understand better. Okay, I have already drawn the matrix and all, so that will save a little bit time in the video, and this video will be a little shorter so that it will be good for you only. Yeah, let's understand. So let's say we are standing at this point. This is my point. So you have two options to move. Either you can move to the right or you can move to the down. Yep. Let's say again you're standing here. You can either move right, you can either move down. Let's say I'm standing here. I can either move down, I can either move right. From here again, I can either move down, I cannot move outside the matrix. So this is a wrong value, right? So again here, let's see, you can either move right, you can either move down. From here again, you can either move down, cannot move right. From here, you have two again options, right or bottom, which is not a valid way to travel. So you will not travel this side. So again at this point you will travel, you have two options, so either go this side, either go down side. That's it. So if you understand this, what I did right now, you'll understand everything. This is what the complete crux of the question is, right? And let's see, let's move ahead. So this question we're going to be solving using recursion first, and then we will do memoization of that, because we'll understand. See, there is an overlapping problem in this question, so I'll show you this and you'll understand. So this is the point where I'm standing, source, and I have to move from here to here. So source right now 0 comma 0, I have two options to move, right? Either to my down, either to my down or my right. This is my right, sorry, first row. Yeah, this is my down, this is my right. Again for this point you have two options, down or right. Again for this you have down or right. Again for this you have down or right. So see, destination is 2 and 2. At this point you reach, this is out of your what, of your out of your matrix, right? So this is not the valid way to travel. So this will return a max value, because you have to find a minimum value, right? So here you can return an int max value, infinity you can return to this. And yeah, this is a valid condition. So see, understand this first. Okay, here I am calculating 1 comma 2. Again here I am calculating 1.1 comma 2 for first row, second column. I am again calculating it. So see, here also I am calculating 1 comma 2. For 2 comma 1 you can see here, 2 comma 1 you can see here, 2 comma 1 you see here. So there is a sub overlapping problem here. Okay, the recursion call that I did is already been calculated in this left recursion tree. It's already been calculated. What? So there is no point of calculating this side, right? So that is the thing. So let's code and see, you'll understand, it's not that difficult. Let's come back. Yeah. So first thing we're going to do is calculate the, let's write the recursive code first and then we'll memorize it later. It will be a little bit easier for that. Yeah, so let's calculate the row, number of rows in this matrix, particularly length. Let's calculate it, calculate the column, which is going to be grid of length comma 0. Yeah, okay. What else do I need? Okay, nothing. So I'll make a recursive call. So I have to provide what is my source of row and column. At what point you're starting? You're starting from 0th row, 0th column, and you're traversing till n m along with the grid. That's it. Again, this function, this will give me a int value. This is where you need to understand int row, int column, int n, int m, and this is the grid they have given us. Let's write it mat. Okay, to make it understand better, let's use grid only. Yeah, so if at any point, if my row is going out of bound is what? Either 3. So at this point, when you calculated the row, you got 3, right? And the column is also 3 for this particular matrix that they have given us in the question description, this example 3 3. So whenever my row reaches n, whenever my row reaches n, this point, this is out of matrix, right? Or my column also is greater than equal to m, so I need to return a maximum value. Okay, integer dot max value. If my row equals to n minus 1, if my you know the traversing that I'm doing, row and column, both are standing at the destination, the row will become n minus 1 and column will become m minus 1. At this point, I'll return my whatever value you have at the destination. So return this grid of n minus 1. Okay, n minus 1 and m minus 1, which is going to be same, so you can use either n minus 1 or row, it doesn't matter. So yeah, you are going to do a two recursive call. So one from right, one for right and one for call, one for right and one second for right and down. We have two options to move. Yeah. So when you're going down, which means you're increasing your row. So row plus 1, column will be as it is, and m is your destination. You cannot change that. That's it. Row will be same here, and you're going to right side. The column will increase. Column increased, and it will be as it is. M will be as it is, and you can use grid here. So you have right and left, right and down. Yeah. So here, what I'm going to do is, yeah, this is the case you need to understand. I'll write the code and I'll explain it later. Okay. So row and column plus math dot min of right comma down. Let's run and see this line. I'm going to explain you in the diagram, so don't worry about it. I'm just first checking it's working or not. Okay, integer dot max value. Okay, integer dot max value, sorry, I think this should work. Yes, it's working. So let's understand here. Okay, okay, yeah. So what I wrote is, see, in how many ways can I reach at this point? How can I reach here? From right and down. This is one way. Second way will be either right, down, and then right. So there are two ways that I can come to 5 from. What are those two ways? From here to here or here to here. Okay, let's understand. Okay, so first thing, okay, how many ways are there to travel from here, this point, this point? Only one way. You can go right, right. That's it. One right here, one right here. So there is only one way. So this is the minimum value for me. So it will be like 1 4 1 5. If you do a sum, when you reached from the source to here, it will become 4, right? Second way, for this point you will move from this point is the only point where I can come from, right? So 4 plus 1, and when I am coming here, how many ways are that I can reach here? Only one way, bottom. So this will be 2. So which is minimum? 4 is minimum or 2 is minimum? So I can see simply this is the minimum value from my up or down, from wherever I can come. There are only two ways, right? Either you can come from up or you can come from left side. So which is minimum for me? 2 is minimum for me. So I'll use this value here. Minimum of my right and minimum of my up, and my current. I'll do the sum. So the current value sum I have to do from my minimum, earlier minimum what I got now for the sum, that plus my current value. That's it. Minimum of 4 and 2 and this. So let's understand for this case. So I'm standing here. What I'm going to do is take a minimum value 1 plus 2. 1 plus 1 is 2. 2 plus 4 is 6. For this you have 1 plus 3 4. 4 plus 5 is 9. So if I have to reach 2, which is my minimum value, 9 or 6? 6, right? So you'll choose this. That's it. This is what I've written here. Nothing else. So if you simply write this code once, I think you'll understand. So yeah, I explained you the overlapping issue that is going on here in this recursive tree. So we can do what? We can send a DP array so that we can use that DP, and if that value is already, if that recursive call is already been used, we won't have to do a recursion call for that again. We'll get the value from the array, DP array here. That's it. And the size of this will be n, and m will initialize every value inside this matrix with a negative value. Okay, and if at any point this is not been calculated already, we'll use that. And j is equal to 0, j greater than m, j plus plus, yeah, dp of I, dp of ij equals to -1. That's it. Yeah, at every recursion call I'll send the dp as well. Open close, dp, dp, dp. Yeah. So before storing the value, before returning the value, you store this in my current index. This is going to be like this. That's it. And if at any point I see if dp of my current row, current column is not equal to -1, which means it has already been calculated because I'm storing every value here. See, then do nothing, then simply return me the current value whichever I have stored there. That's it. That's it. Yeah, let's run and see this. It's working or not. I think this should work. Yeah, that's it. So we'll understand the tabulation way now. Yeah, it's working. So let's do a tabulation. Let's do our tabulation code now. Okay. So let's understand the tabulation code. Okay. So let's say I'm standing here. There is only one way to travel from 0, 0 to 0, comma 2, right? Only one way. You can move right and again a right. So initially what we'll do is we'll do the sum already. There is only one way to move. So this will be 1. 3 plus 1 will be 4. 4 plus 1 will be 5. Okay. 1 plus 1 will be 2. 1 plus 4, 2. 2 plus 4 will be 6. So initially what you'll do is you'll create one DP matrix. Okay. Let's, sorry for the diagram. It's really messy, but yeah, 1 4 5, and this will be 2 and 6. So see, at any point I explained you already that you can either come from upside or your left side, right? So what is minimum for 2 and 4? 2 is the minimum value, right? 2 what is my current value here? 5. 5 plus 2 is 7. Write 7 here. Okay, 5. So from for this you can either come from up or right. Which is minimum from for your previous row or previous column? Which is minimum? This or this? 5 is minimum. 5 plus 1. My current value is 1. So do a 6 here. So you'll always store a minimum value there. It's really simple. When I'll code, you'll understand. So 6 or 7, which is smaller? 6 is smaller. 6 plus my current value is 8. I'll store 8 here. So for this point, I can come from here or here. See, I want to reach here. I can come from here or come from there. So 6 is minimum or 8 is minimum? 6 is minimum, right? And current value here in this is 1. 6 plus 1 is 7. If you'll go and see the you know question description in the example, you'll see 7 is your answer. This is what we got this way. 1 plus 3, 4, 4 plus 1, 5, 5 plus 1, 6, plus 1, 7. That's it. That's it. And nothing else. So yeah, let's write the code. You'll understand it better when I'm writing it. So let's do that. Okay. Grid dot length int m is equals to what? Grid of 0 dot length. Let's create the DP that I was talking about. New int n plus. Okay, let's use n only because n plus 1 will give you 4. Yeah. And initially what I'll do is I'll do a kind of a prefix sum to store all the values there. So I'll have one value sum with me, int I n. So this time I'm doing what? Sum plus equals to whatever value I have at my, the row is changing here. The row will change, the column will be static. So column will be same. So this part, this is the part I'm doing right now. The row is changing. This is 0 0, this is 1 0, this is 2 0. So column will always be 0. That's it. And I'll store that in my DP of I will be changing and column will be same. That's it. Sum done. Same for column. Now sum has, sum has again some value. We will initialize it again with 0. We'll do the same thing for the column now. J0, J will traverse on M, J plus plus. That's it. Sum plus equals to grid of J will be changing. So this will be 0 and J will be like this. And what? DP of I will be same. So it will be 0 and J and sum. So now I have traverse in my complete, first row and first column. So now the loop that I'll be writing is from going to be from second row and second column. Yep. Let's do that. For int j equals to 1, j greater than m, j plus plus. So you have two options to use now. You have two options. What is that? One is my left side. Left side will be what? DP of I minus 1. Left side will be not I minus 1. That will be in column, sorry. So DP of I and j minus 1. I j minus 1. So when you're standing at 1 1, you are coming from left. So this is what? J is decreasing here. So from here, this you can reach 5 from 1 na? From this place you can move. So that's what I'm written here. Again I'll write for up. When I'm coming from up, the row will change. So I minus 1 and J will be same. Now what I did, what I told you, that you will assign the value at that index. How? By my current value that I'm going to use, ij, plus whatever is minimum from my previous row or previous column, whatever. So whatever is coming minimum from my left or up, so whichever is minimum, I'll use that and I'll store it, and at the end I can find, when I'm reached the destination, you can use that part. So it will be like n minus 1 and m minus 1. Yeah, I think this is done. Let's run and see if it's working or not. It's really simple, you simply need to understand, yeah, when I'm standing at this point, how many ways I can reach here. There are only two ways to reach at any point you are standing at, either from up, either from left. You can use the minimum value whichever is giving you, and whatever is the minimum value, you can do the sum of my current grid. That's it. This is what, once you'll code, you'll understand better. Hope you understood the question. And yeah, I'll see you in the next question. Let's submit and see this first, and yeah, I'll see you in this next question. Yep, this is working fine. Hope you got this. Okay, thanks.